Video successfully launched. Start. Okay. Hi everybody, and welcome to new frontiers in browser games and browser applications in general coming true. Now, can you see? Okay, I'm using now this browser's internal magnification tool, so that maybe you can see it better on the video recording. You see this line, this greenish line, bluish, greenish, whatever. And look when the road segment appears. Look what happens when it disappears, because here we use hard clipping for the segments of roads, because it's a testing mode. This is a testing mode of the Phalanster City 3D urban environment rendering engine, and also a game, something that can be used as a game similar to GTA 1 and 2, and for the complexity of the environment, the complexity that the environment can display, similar for many reasons also to GTA 3. It's all. Now look this line, this curvy line, and then we let reappear this segment, and we see that the greenish bluish line is perfectly aligned with the, look here, with one of the sides of the segment of road, apart from minor graphical glitches, but we will speak about them too. And well, that line is, if we do now some trick, hey, moment please. We get close to some of these elements, and sorry, I'm a bit, moment please, because using the arrows causes also the page to scroll. If we go near one of these, we see that it's polygonal. It's a polyline. And well, the polyline connecting sample points of the Bezier-curve, forming one of the sides of the road. We can see that it's a bit polygonal, polyline. Okay, and here maybe we can see some edges that it's not a perfect curve. Well, the sample points are generated by an internal procedure that I added recently, yesterday, in the program. Look, here are the things to reconstruct the Bezier-curve, that expression from which we can have any point laying along it. And this means that now, as soon as the bounding box stuff is completed, and the procedure, which is at the heart of the map system version 1 algorithm, which I developed years ago, it can detect the contact of a point with the segment of road. It can say, where are you making contact, and what height the point has to be. One can do roaming on a completely multi-level network of roads. And what does this mean? That we are achieving, I am achieving, a goal which was originally, which I thought to be further. I am achieving it at a lightning speed. At version 1.4, now let me turn down this stuff and do the video better. Okay, okay. Now that I thought that initially, well, only I can't play and speak at the same time. Let me move the notes here. I have to. Sorry if this is all a bit informal, but this is just an update, quick update video. However important the content is. This is better now. Okay. Turn this down. Now, well, the fact of passing directly the usage of the originally conceived Bezier-curves, curvilinear segments of roads, everything as in the map system, original map system version 1 library. I found it much easier to directly implement that using Bezier-curves, not the normal polynomial interpolation which I used instead. I chose to use in the original map system version 1 thing, as I said in the old video. I was not a big guru of using Bezier-curves because I've never been involved in like civil engineering and so on, and I'm not a. It was somehow outside any context where Bezier-curves, these things are used, and I said, okay, let's go with normal polynomial interpolation, even if clearly for any industrial strength stuff, a little update of the map system program to the usage of Bezier-curves would have been needed, as stated in its documentation, as I stated there. But the whole, I have dipped a little bit into the Bezier-curve stuff, and I realized that hey, it's much easier to implement like that I thought, and that okay, we can, that the next version of the Financial City 3D urban environment rendering engine and GTA like Grand Theft Auto like game, browser game, well, it will become fantastic just in question of little time that I implement the full heart of the map systems algorithm, which puts the point, says a point where on which segment of road is roaming, and if it's roaming on a segment of road, and does this correctly even when there is, all looking from above, there is a multi-level. There are roads above where it could be and below, but this algorithm keeps track of where it is going and does it in a very light way, and that's fantastic. So question of 2-3 things, one module, 2-3 functions, very short ones to implement, and we have the full thing ready, which means that the restriction that originally I had thought for the Financial Cities 3D's next version, which will be version 1.4, that was about having only for roads, segments of roads which are not planned like this but allow to climb on something, the sorts of trampoline, that they could not be curvilinear, and that on curvilinear segments there would be detected no, the contact with the curvilinear segment would not be detected at all for the cars, for the giving more grip to it, and letting it run correctly on an elevated highway, which is a non-zero ground zero level segment. Therefore, for which it would follow that the car just goes at level 0 and nothing. It will do everything, fully general, and here comes the thing that I called this very little video update, new frontiers in browser games. Seriously, because it allows to do, since it's total general, we have here 3-dimensional Bezier curves, not 2-dimensional, 3-dimensional full. One can do also, thanks to a little enhancement in the map system, because this is a re-implementation of a mixture of map system algorithm version 1 and version like 1.1, just some little enhancements. One of the enhancements is the static roaming, so that it does function fantastic. You can also avoid having to use physics of things that fall down and just solve the roaming on roads, like just considering core point that is falling, but then when it hits ground it rebounces and then it stops there. And in a segment of road stuff it does the same, because you push it, it rebounces and it climbs. For this I developed a little enhancement which allows a very stable static roaming, that is a completely non-physical kind of, according to the route that one made on which segment of road went in what direction. The algorithm knows, based on the history of movements of the point, on which segment it is, and it just gives it, it's here, it's at this point, and the height of the road is there. And the roads, yes, can be also so, and also you can do construct if you put some effort into designing it, each segment of that. Carefully, look, you can do an upside down turn interface facility like this, and also that is non-physically, it's static roaming. So absolutely general, fantastic. The only thing that there won't be is the ability of the possibility to have variable width segments of road, and segments of roads whose lateral steepiness can do so. But that's just ridiculously simple to add to it. It's not present in map system version 1, except the width stuff. It's the same, and there is extremely complex environments which can be defined, environments where the focus is on the segments of a network of roads. Extremely complex things can be defined like extremely simple, like ridiculously just incredible, thanks to usage of Bezier curves inside the context of the main idea, the heart of the map system library algorithm that, as I said, I developed years ago, but in C++. And reason why probably it didn't really get into any application, but this is a browser application. This works on every platform. This is instantly functioning. And what I have forgotten to say the other times of the Falanster City 3D thing is that I found out that there are some browsers, in our case the Chromium named browser, which, for example, executes this program much faster than, for example, Firefox, the Firefox named browser. I haven't tried with other things, but with Chromium it's super fast, but it has graphical glitches, probably because, okay, we don't go into details. With Firefox is a bit slower, but the graphics is okay. And one addition, as I said, I had dipped into a bit of Bezier-curve stuff, and I correctly, as I had predicted, it's possible to automate fully the correction of some graphical glitches where a segment of road is not correctly covered by an obstacle that is in front of it, or like so. And I found out that there isn't even the need to work out a method to split, because all this needs is splitting Bezier-curve. That's a segment of road like those I try to show, splitting it into at some point that make two shorter segments which anyway fit together to form practically the original one. And I found out that there isn't even need to develop a method, because it's called the Decasteljow algorithm, which does the splitting, and so it's simply enough to read and implement. And the automatic control of non-intersections, like no segments of roads like intersect buildings, and so automatic splitting of non-correct definitions can be done at initialization. The top-down view can help a lot, but this can be used also for non-top-down view, even if clearly it makes it slower. It's not so important, but for now it's all that. Hope it wasn't too boring. Whatever. So these new frontiers are coming through with Financial City 3D rendering engine, and I say again, it's some looking at these results, some sponsorization would be great, because could lead really to things that could or would have been hard to imagine. Say again, this program is extremely lightweight in its system requirements. It runs smoothly, and also a very low-end system. There is the spare graphical mode, which uses top-down view, and so it skips some calculations that are needed in that case, and with that mode is really fast, and whatever. I hope to come out with version 1.4, which will be fantastic new frontiers. Like, I wanted to show you a similar program, but I don't have it on the other computer. A three-dimensional game that, like, hey, when one sees it, it's called Car World. One can go with a car on very well looking, like, curvilinear roads. It's like nothing under GTA 5 or whatever, but that's within C++. Hey, and that game is like, one sees it. And hell, practically this will, in the next version, do practically the same job, with the only difference that it's mostly working well with a top-down view, and it's not so. There is some hack the physics for the cars. It's not yet possible to switch to fully 3D simulation of the car's dynamics to make it really that good. But this is a browser game. This algorithm is being made. This whole procedure, whole rendering engine, with all that it offers, is being made really so minimal, so short, that it's like like a extremely sharp knife cutting piece of butter. It does all and only what is needed, and it does it excellently, using for each subtask the best tool available, theoretical tool. So hi, and this was Simon, alias the Nerd of Algorithms, and today was the 3rd of July, year 2016, and sorry for the low quality sound, but I told about that problem in another video. That's what I could afford to do so far, because I have to work on the next version of this fantastic web-based application, and also browser game. End of record.